In this section 3, we'll be talking about the law of diminishing marginal returns and the marginal rate of technical substitution. The theorem, the law of diminishing marginal returns, or basically the marginal product keep falling as more and more of inputs is employed. So if you're fixing the amount of other input, the marginal product of an input eventually diminishes as its quantity increases. In mathematical terms, it means that NPL is decreasing in L given K, and NPK is decreasing in K given L, or the second derivatives of FLL, or partial derivative of F with respect to L twice, and the FKK, partial derivative of F with respect to K twice, are both negative. Right? So just try to just gonna convince you like the concept of diminishing marginal returns. Let's say that I have a capital and labor, and let's say that I fix capital. So my capital is this size of land that is fixed. So I have this land, right? And then I want to grow some corns, right? So I can put one labor, 1 unit of L, and then grow corn, right? So this 1 unit of labor can work on this field, this fixed amount of K, this size of land, and then grow some corn. So the corn that I grow with 1 unit of labor is gonna be my total output using 1 unit of labor, right? But then I can also add more labor into this. So with 2 laborers working together in the same land, in the same field, in the same farm, then my total product we would expect to increase, right? Because marginal product to labor is positive. If you have more labor, you would expect more total output, right? But then you will have the marginal product of this second unit of labor, right? The marginal product of this second unit of labor might be higher than the marginal product of the first labor because, okay, there's still plenty of, of lands to go to work with. Then I keep adding more and more labor, right? So as you can see that now it's getting a little bit cramped here. So now we have 6 laborers working on 1 unit of capital. If I decided to add 1 more labor here, my marginal product of this 7th unit of labor would actually start to fall, right? This would be smaller than the marginal product of this second last unit of labor. And if they just keep adding more and more labor, then you would expect marginal product to be actually smaller and smaller and smaller. It's still positive. It just become smaller positive marginal product, right? Because it just become like you exhaust this fixed capital unless you allow capital to increase, right? You increase the size of the field then, but that would not be applicable to the law of diminishing marginal returns, because for the law of diminishing marginal returns, you have to fix, the other inputs. In the case K is fixed, and to keep adding, the other inputs keep adding more and more, then of course the marginal product will become smaller and smaller and smaller, but the total input would increase, but it just increased in the smaller rate. So we know that MPL and MPK must be positive, right? What that means is that when you increase 1 unit of labor, your total product will increase. Or when you increase 1 unit of capital, total product will increase. That means a positive value of marginal product to labor and the marginal product to capital. But if you take the derivative of the marginal product, right? So this is called FLL, which is either you take the derivative of these functions twice, which is also equal to the partial derivative of marginal product to labor with marginal with labor, right? So these are all equivalent. So what it shows, it shows the change of the marginal product when 1 unit of labor increases, right? In this case, this is negative, has to be negative because your marginal product actually gonna decrease as L increase, but marginal product value itself is positive. So don't get confused about this. And if you change it to K, FKK, right? Gonna be the same. And it's called law of diminishing marginal returns, right? When you increase, when you fix other input constant and keep adding more input, more unit of the other inputs, then the marginal product of that input will become, will be falling. Now we can, if you look at this, this isoquants, you can see a series of isoquants, right? The first one, the output is 55. The second one, the output is 75. And the third one, the highest one, the output is 90. So to move from this to that, the output increases by 20 units. From this point to that point, the output increased by only 15 units, right? When you look at this diagram, what you see is we fix K. K is fixed as equal to 3, but we allow L to increase by 1 unit. So when L increases by 1 unit, my marginal product of the second unit of labor is equal to 20. Do you see that? Marginal product of the second unit of labor would be equal to the total product or total product of 2 units of labor less total product of 1 unit of labor, right? Given that K is fixed, right? So the total product of 2 units of labor is equal to 75. And the total product of 1 unit of labor is 55. That's how we got 20. That is MP2. Then MP3. MP3 is total product of 3 units of labor less total product of using only 2 units of labor. That is marginal product of the third unit of labor. Right? So total product of 3 units of labor is equal to 90. Right? 90 less 75, that is equal to 15. Now you can see that as more and more L increases, right? Marginal product actually still positive, but it gets smaller and smaller as you move on to the marginal product of the first unit of labor. These values to become less and less, right? Or as you can see that it is like the same distance here, right? The same distance, 1 unit of labor, but the amount of output actually doesn't increase in the same rate. It increased in the smaller rate, and that is because the FLL, or the change in the marginal product is actually negative. And you could do the same, that instead now we fix L equal to 3 and we allow K to change by 1 unit. So if you look at this, the same thing, right? When K, so you can see that marginal product to capital of the second unit of capital would be 20. MPK of the third unit of capital is 15, right? The same, that we have decreasing function of the MPK or FKK is negative. Own effects and the cross effects. When there are 2 inputs, increasing the amount of one input may affect the marginal product of the other as well. So let's say we know how to compute MPL, which is FL, and MPK, which is FK, right? What happened is if instead we say, okay, what happened to MPL if instead of L changes, now K changes? How would it affect MPL, right? Or what happened to MPK if L actually changes? So this is called like the cross effect. And if increasing the amount of one input may affect the marginal product of the other as well. So we typically impose an assumption on this cross effect that magnitude-wise, the effect on the input's marginal product due to an increase in this particular input is bigger than that due to an increase in the other input, right? Mathematically, this is the effect of the on effect, right? When you change L, how does it affect MPL? When you change K, how does it affect MPK? This term, when you change K, how does it affect MPL? For this one, when you change L, how much it affects MPK? So this is the on effect, whereas this is the cross effect, right? So if we assume if we assume that the on effect is actually dominates the cross effect, that means this term must be bigger than the cross effects, or this one had less, this term has to be positive, right? This condition is sometimes known as on effect is bigger than the cross effect. And we will be revisit this, this condition a little bit more later. Just as in consumer theory, we assume that diminishing marginal rate of technical substitution, that is along an isoquant, as the amount of L increases, the absolute value of MRTS decreases, or just the isoquant will become flatter and flatter, right? As we move down along the isoquant, so it becomes flatter and flatter. Intuitively, holding output constant, it is harder to substitute capital with labor as the capital labor ratio fall, or it is harder to substitute labor with capital as the capital per labor ratio increases. This is similar to the average is better than extreme type of assumption. Remember what is it in the consumer theory? What property is this? Average is better than extreme. That is strict convex preference, right? And remember, when we have strict convex preference is when our indifference curve, so this is put X and put Y, when our indifference curve look like that, then the average, right, is strictly preferred to the extreme, or average is better than extreme. And that is a strict convex preference. And for this, for the diminishing marginal rate of substitution is pretty much the same as the strict convex preference there. We have L and K. So what it says that as you move down along the isoquant, right, it becomes flatter and flatter, or it becomes more and more difficult to substitute K with L, because now you have a lot of KL and not so many K, so it becomes more and more difficult. So it turns out that if we assume that diminishing marginal returns to labor and diminishing marginal returns to capital, or FKK, is negative, and also the on effect is bigger than the cross effect, which is this, then we guarantee that we would have diminishing MRTS. So if we have this condition, and this condition, it implies that we must have diminishing MRTS. However, the other way around is not true. So that means that if we start with diminishing marginal rate of substitution, we do not always have this condition. These are just like guarantee. If you have this, and this, it would follow this. But if you have this, it doesn't imply this or that. Okay.